Pandas exposes a simple-to-use interface to visualize data. The supported visualization methods are all available using a data frame's plot property as dataframe.plot.method. Key visualization methods include line, which produces line plots of the series in a data frame, hist, which produces histograms, KDE, which produces kernel density plots that are smooth versions of histograms, and scatter plots. These are all wrappers around matplotlib's pyplot methods. The matplotlib methods can be directly used, and in some cases, they expose additional options. Finally, the Seaborn package, which is included in Anaconda, supplies a simple method that changes the default appearance of plots. I believe that the alterations made by Seaborn improve the quality of most visualizations. I'm going to use PyCharm in this lesson. I'll start by opening Lesson 21's notebook. First, we need to run the cell that contains the funny-looking command %matplotlib inline. This tells Jupyter to produce line plots inline with the output of the cells. It is needed anytime we produce visualizations in a notebook. Next, we need to import the data that we will visualize. The data is high-frequency transaction prices for IBM and Microsoft. The data is stored in HDF, and so we import it using read HDF. Start by importing pandas using its canonical name, PD. pd.readhdf, followed by the file name, data-hf.h5, and finally the key. We can assign this to IBM to hold the data. The Microsoft data is loaded using the same structure, only with the key msft and a different variable name. We can look at the Microsoft data using msft.head. We see that the index contains the timestamps and that there is about one transaction every second. Line plots are produced using the plot method attached to a data frame or a series. This interface closely matches the methods available in df.plot.line. These methods plot the data in a series or a data frame as y values against the data frame's index as the x values. These can be overridden using the keyword arguments x to specify a column name to use as the x coordinates, and y to specify the column or set of columns to plot from the data frame. The appearance of a line plot can be altered by changing the line width, the line style, the marker, or the color. A large set of additional options are described in the help of matplotlib's plot function. Basic line plots are produced by calling the plot method on a data frame or series. Let us start by plotting the IBM data. Running this cell produces a plot of the price series. The plot function returns an axis instance, which we can capture by assigning the output to a variable ax. Running the cell shows this is an axis subplot. Next, we'll use the axis to add a title and labels. Start by creating a new plot and capturing the axis. We add a title to a plot by calling the method setTitle on the axes. The input to this function is the title string. We can add axes labels using the same structure, only using the setXLabel and setYLabel methods. The X label is set using ax.setXLabel followed by the label string time. Setting the Y label is essentially identical. Here, I will use price as the label. Running the cell produces a plot with a title and axis labels. The final task asks us to plot the IBM data using a marker and no line. Line styles are modified using the keyword argument line style. Here, I will set line style equal to the text string none, which removes the line that connects the points. Markers are added when calling the plot function using the marker keyword. Here, I'm going to use V to place a downward triangle at every point. I will copy the title and labels from the previous cell. Running the cell produces a plot without a connecting line and with markers. The next problem introduces subplots. We need to use a method from matplotlib_pyplot to create the axes to hold the subplots. Let us start by importing matplotlib.pyplot using its canonical name. Before completing the problem, I'm going to highlight some small changes that improve the aesthetic of the default format. The first sets a property of matplotlib's RC that changes the figure size. Next, I'm going to import Seaborn. I will use the Seaborn function setStyle to change the default plot style to dark grid. This will produce plots with a gridded background that makes it easier to see the important tick markers. There are 4 styles defined in Seaborn. It's worth taking a look to see which one you like the best. With these small changes made, we can get on with the problem. First, we start by calling plt.subplots, which creates a figure and the number of axes we need. I will use the 2 input version, which defines the number of rows 2 and the number of columns 1 that I want. This function produces 2 outputs, and so I will directly assign the figure and the axes here. The axes are a list of axes with a shape that matches the number of rows and columns of the subplot. Since this is a 2x1, there are 2 axes in the list. We can plot IBM by calling plot and specifying the keyword argument AX equals axes bracket 0, which is the first set of axes in the plot. I'm going to show off some of the keyword arguments of plot that we can use to alter the appearance. I will set the line width to 3, which produces a thicker line than the standard plot. Next, I will plot Microsoft in the second axis by calling plot with AX equal to axes bracket 1, which is the second set of axes. I will change the color by setting color equal to orange. You can use common English names or web-style hex colors, which are a hash followed by 6 hexadecimal numbers. Finally, I will change the default line style from solid to dash dot. There are 4 different line styles available. Running the cell produces a 2x1 set of plots. I like to use one more line to improve the appearance of subplots. I like to set tight layout on the figure. I can do this by entering fig.tightLayout with the input pad equals 1.0. This makes some small improvements to the spacing between the plots. The final problem shows us we can produce a plot using the plot function available through pyplot in matplotlib. This function needs both the x and the y coordinates of the line. We start by calling plt.plot followed by ibm.index, the x values, and ibm.values, the y values. Running the cell produces the plot. This has left some empty space before and after the plot. I do not like this, so I'll grab the axes using plt.gca, which is an abbreviation of getCurrentAxes. This function returns the most recent set of axes created. I can then call setXlib on these axes using the first and last value of the index, index 0, and index -1. Running the cell one final time produces a better looking plot. df.plot or df.plot.line both produce line plots. These are both wrappers for plt.plot. Many properties can be changed using the setProperty method of an axes instance. In this assignment, we saw examples of setTitle, set X and Y labels, and setting xlib. Finally, Seaborn provides an improved default style that leads to clearer, better-looking visualizations.